Hello guys, welcome back to Little Code. Today let's practice a HackerRank question. Fraudulent activity notifications. So here is a list. In the window size, D equals to, in this example, is 3. And we want to find out the median number in the window size. In this window, let's say this window is 3, so we have 10 and 20 and 30. So the median number is 2 and 20. And if the E of I is greater or equals to 2 multiplied by the median, so let's say the E of I is the first element after the window, so that is 40. The 40 is, if this 40 satisfy this condition, and we will add our notification by 1. So the question asks how many notifications there will be. Okay, so here 40 is greater or equals to 20 multiplied by 2, right? This one is also the 40. So our notification will be at least 1. And then we will move our window to the next window. So we will move the window from 10 to 10, 20, 30 to 20, 30, 40. In this window, the median number is 30. And the E of I is 50, and the 50 is not bigger or equals to 2 multiplied by 30, that is 60. So we would not add our notification by 1. And for the next window, we will move right again, and then it will go from 30 to 40 to 50. But since the window already reached the end of the list, so there is no E of I, so we will end the iteration. So the notification is just 1. Okay, so this one is a simple example because the array here is already sorted, but it is not guaranteed to be sorted. So the difficult part of this question is find out the median number without sorted multiple times, because we have to move our windows, right? But we don't want to sort the array every time when we move the window. So that is a difficult part. And another hint here is that you can see from here, the E of I lies from 0 to 200. So every element in this list is 0 or 200. So this is a fixed size. And when the number in the list or array is fixed, in a fixed size, then you can always think about bucket sort or county sort to sort the elements in the array. That is like a linear time complexity, which is better than the n log n. We can try to use a county sort here. So now I will use a more complicated example to elaborate. Okay, let's use this example. So now we have a d equals to 5. So we know that the median number is the third number in the window if the window is sorted. To use a counting sort, we will have another array, and the size of the array is the range of the elements in the array. So we will have a range that's from 0 to 200. So we want to have our array size of 201. So here is the array. Another array we will use in counting sort. In this array, the index is the number in the E list, and the number in the array like this one will be the frequency of the number in the E list. Okay, so first, in the first window, since d equals to 5, so we'll have the window size is like this one. And let's put, so first we'll have a 2. So we have one frequency or one occurrence of 2, and the 3, and the 4, and 2. So now we have 2 of 2. So it comes to 2. And then 3. So it will goes from 1 to 2. And then after finish the fill in the array, let's find out the third number in the window. Okay, so now we know that we have 2 of 2. So we'll have another variable, let's call it counter. So we'll have a 2 of 2. And then next we'll find out, oh, here is another 2. So this one is 4, and 4 is bigger or equal to 3. So since we start from the small number, and actually we'll start from 0, but here is 0, so I skip this one, this 2. So we start from the 2, and then we know there are 2 of 2, and then 2 of 3. So, and we want to find out the third number, the third number in the array if the array is sorted. So now from this one, we know that the third number in the array, it will comes to 3, because here is will goes from 2 to 4 here. In this first window, the median number will be 3. Okay, and for the next window, so we will start from 3, 4, 2, 3 to 6. Okay, so we want to first remove this element or this frequency from our counting sort array. That is 2, so we'll decrease the 2 by 1. So we'll go back to 1. And then we will have another 6 here. So the frequency of 6 is now goes to 1. And again, let's check the counter. So we'll start from in the beginning of the array. So here is a 0, and then 0, and then here is a 1. So we have a 1 here, and then we have a 2. So 1 plus 2 is 3. So that is equals to the median number here. So we know the median number in the green window is also a 3. Okay. And next we will move our window again. So we'll start from 4, 2, 3, 6 to 8. So we want to remove the 3. So the 3 will goes from 2 to 1. And we will have a new 8. So the frequency of 8 now is 1. And then let's check counter. So we'll have a 1 here, 1 here, and a 1 here. So when the counter is 3, we find out, okay, the number is 4. So the median number in this window is 4. Okay, so that is how we find out the median number in each window without have to sorting the array again in multiple times. Okay, so here is a tricky part. The median number in the array, when the array size is odd, like this one, is when it is 5, there is only one median number. But if the array size, let's say, is 6, then the third and the fourth number in the array, in the sorted array, will both be the median number. So in this one, we'll find out 2 median numbers. And how do we find out that? That is easy. So we will have a counter and check when the counter is bigger or equals to 3, and then that is the first median number. And when the counter is greater or equals to 4, and that is the next median number. So for the time complexity and space complexity, for the space complexity, we'll have this array. And since the size of this array is fixed, is always 201. So the space complexity is a constant. Okay, for the time complexity, we will iterate the E list. Like we'll move our window, and we'll first put our window in the first element in the array and check when you reach the end of the array. So that will have n iteration, and for every iteration we want to check this array from the 0 to the end. Okay, it should end at 200. So this one is a fixed size, so this is a 200, and so the time complexity here is 200 multiplied by the size of the list. So the time complexity here is a linear time complexity. So first, we want to have a new array. So that is a new array, integer array. So let's call it county sort. And it will have a size of 201. So we want to fill in the first D elements in the county sort array. So for every elements in this one expenditure, then we want to add the frequency in the counting sort. So that is here is the expenditure that gets I and increase by 1. Okay, we have finished the first D elements, and then we want to find out the median number. Okay, so let's use another function to find out the median number. So it will have two variables. So the first one is the counting sort array, and the second one is the window size. Okay, so now we want to process the two conditions here. So first is when the array size or the D is odd, then there is only one median number. And the second is if the D is an even number, then there will have two median numbers. So what I do here is I will use suppose there are two median numbers, and then after I finish the calculating, then I will return just one number or the combine of two median number by checking whether the D is odd or even. Okay. So this is the first median number and the second median number, and I would like to initialize them as negative number to signal that these two are not being calculated. Okay, so the first median number, it will in the D divided by 2, it will lies in this position, and the second one will lies in D divided by 2 but plus 1, this position. Okay, and then I will have another I will have a counter equals to 0. So I would like to iterate through this counting sort and add their frequency into the counter, and then I will check when the counter reach AC1, then it means it finds out the M1, and if it reach C2, then it finds out the M2. Okay, so initialize at 0 is smaller than equals to the size of the search. So every time I will increase the counter by the frequency in the county search. So that is. And then I will check if the counter has already bypassed C1 or C2. So since the C1 is smaller, we can use process C1 first. Okay, here is C1. So so this way we can know that because our counter will keep going larger and larger after it reaches C1. So in order not to override the number we already have in M1, I will check if the M1 is not being calculated. So I will check if it is an initial number that is a -1 here. Then if that's true, it means I found my M1. So here I found my N2 and I can break. So I don't have to iterate the whole counting search. I just have to find out the median number. So maybe that is the very beginning of the counting search array, so we can save some time. So now we can return. So let's first check whether the D is odd number or an even number. So if that one is an odd number, okay, if that one is an odd number, that means the median number lies in M2. Okay, so because here is an integer here, and the median number, when there are two median numbers, so I'll have to use M1 plus by M2 and divide by 2 and then return that. But since we have to calculate the 2 multiplied by the median numbers, so I will just return the multiplication of 2 here. So we don't have to process the division here, so we can always return an integer. Okay. So here I will use 2 multiplied by M2. And if that is an even number, that is why I will return M1 plus M2. Okay. So that is how we find out the median number. So in this function, so here is the number of the notice. Okay, so that is the result we want to return. So now we want to iterate this expenditure from D, because there are the window size is D, so we will start from the D position of the expenditure. So here is the median number. What I call it is find median. So I have two variables, county search and D. So if the expenditure is greater than the 2M, here it should be greater or equals to m. So because we already have 2 here, so here I don't have to use the 2m, just m. If that is true, then I will increase the notice by 1. Okay, and before moving to the next table or next window, I would like to remove the first elements in the window and then add the new element. Okay. So the first element in this window is utilizing I minus D, right? But this is from the expenditure. And add a new one. Okay, and then we can return a notice. Okay, let's run the code. It's great, and then submit. Okay, so I passed all the tests. Thanks for watching. I will keep doing the HackerRank video, so you can leave a message if you want me to do some specific questions. Okay, see you next time. Bye bye.